Hello, it's Mrs. Krantz, Algebra 2 class, Honors Algebra 2. There's Leo, tongue out, sort of sleeping. Zoe with all her toys. Her gnome. See your gnome. Gnome lost his face though. Hope everyone's doing well. It's a rainy day outside here today. Hoping it's going to clear up. Today, this is Honors Algebra 2, Mrs. Krantz. We're doing the ellipse. Now, do you remember how many conic sections are there? Emily, Lily, what do you think? If you said 4, you're right. And we are on the third of the fourth, the ellipse. It's a perfectly symmetrical oval. Okay, it has a center. And then it has actually focus number 1 and focus number 2. And the plural of focus is foci. All right. So different from the parabola, which has a vertex and one focus. You have an ellipse, a perfectly symmetrical oval that has a center and 2 foci. All right. Now, here's what happens in an ellipse. This is a pretty long ellipse, okay? The ellipse can get more and more circular. So if you have a less elongated ellipse, your foci are getting closer to the center of the ellipse, all right? And then if you have a less elongated ellipse, your foci are getting super, super close to the center till all of a sudden the foci come together and they're right in the center, and that is a circle, all right? So these three are an ellipse, 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 and then a circle is really just like a special ellipse, okay? Just like a square is a special what? Do you remember? A square is a special rectangle. All right, so today is, I think I'm going to post this on Thursday, June 16th. All right, 10-4, Honors Algebra 2 with Mrs. Krantz. We're doing the ellipse. All right, the definition of an ellipse. All right, all 4 conic sections start out the same in their definition. Set of all points in a plane. You can call that set of points P, right? Such that. Now, this is where it's different. Quite a bit different, I'd say. Well, a bit different from the other two. The sum of the distances from any point P, all right, on the ellipse, to 2 fixed points, F1 and F2, which we now know are called the foci. That sum of the distances is a given constant, K, all right, a given number, a given distance, all right? Now, please, again, stop the video at any time. You need to write this down. I really encourage you to take these notes. You don't have the notes pages, so you'll have to kind of write more than you typically do, all right? But of course, I'll post the completed notes pages. All right, so here's what we've got. We have an ellipse here. It's not super elongated, all right? You've got what are called 2 endpoints, all right? Those are on what's called the major axis, okay? So the major axis is the longer axis of the ellipse, and it contains the endpoints of the ellipse. And in this case, the endpoints are given by A0, negative A0. And those endpoints are called vertices. So in this case, I've got positive, negative, A, 0. They're right on the x-axis. Okay? If you have a tall ellipse, not a wide one, they could be on the y-axis. So 0, positive, negative A. All right. Now, the major axis has the endpoints, which are called the vertices, and it also has the foci. Okay. So you can see this focus 1, focus 2. It doesn't really matter. You can label this F1, F2. Okay. And the distance from the center to a focus is distance C. The distance from the center to an endpoint or a vertex is the distance A. Okay. So vertices, right? These are the endpoints. All right. And they're given by the distance A. A is the distance from what we call the center of the ellipse to a vertex. Vertices is plural for vertex. All right. Then you have the minor axis, which is, of course, shorter. All right. It contains what are called the co-vertices. Those are given by distance B. Okay. Right. The minor axis does not have the foci. Okay. So here's the minor axis, all right, and B is this distance from the center to a co-vertex. All right. It's given by B. This is the distance. Spelled that wrong. From the center to co-vertex. I call these CVs, I call it B. Okay. Now, I want to go back and explain what this definition means. Okay. So I'm going to erase this. I'm going to go back here. When you read the definition, or I tell you the definition, I do think is a little bit confusing on these, but let me try to explain it, okay? Set of all points in a plane P such that the sum of the distances from any point P, all right, P, to two fixed points, the foci, all right, is a given distance K, all right? So here, let me make up some numbers. Say this distance here is 3, from focus 1 to the point on the ellipse. Say this distance is 7 from P to F2. Okay. The sum of those distances is 10. Okay. So if I pick a different point P, like I let this be my P sub 1, okay? If this distance is now 2, put it here, right? What will this distance be? Right? Well, the sum has to be always the same, a constant, 10. So this distance will be 10 minus 2, 8. Okay? This is what makes a perfect oval called an ellipse. Okay? All right. So, ellipse has its own formulas that come with it. All right. Here is standard form. All right. Not what you're used to saying. All right. Standard form for an ellipse that has a major axis that is either the x-axis or a horizontal axis, where it's longer, wider instead of taller. Here's standard form. It's got an x squared, a y squared, and a plus, okay? And it equals 1, right? X and y are the variables. A and B are going to be numbers, okay? Remember, A is the distance from the center to a vertex. B is the distance from the center to a co-vertex. And here's your formula. It's x squared over a squared plus y squared over b squared equals 1. Every time it's got to be a 1. Okay. Now, If you change it and you make it a tall one, where the major axis is either the y-axis or vertical, it's very similar, except you switch where the a squared and b squared are. They just switch. So b squared is first, then a squared. Okay. Now, there's one other formula we got to know with these. Okay, so I'm going to get some markers here. All right. The distance from the center to a focus, I'll put it in red, is c. Okay, given by just c. Okay. What's the distance from the center to a co-vertex? That is b. Okay. Now notice, there's one more distance. There's the distance from the center to a vertex. This is the longest distance. A, okay, is always going to be bigger than B, and A is also going to be bigger than C. Okay, this is the longest distance. A. And if you took that distance A, all right, and you rotated it, it's actually this distance here. Okay, if you have a perfect ellipse, the distance from the center of it to a vertex, this distance is this distance right here. All right, they're exactly the same. All right. So we have a formula associated with A, B, and C. It is similar to the Pythagorean theorem, but the letters are switched because A is the longest, A is the biggest. So this is going to be B squared plus C squared equals the hypotenuse squared, which is A squared. All right. We're going to be using that formula a lot. Okay, so it's the Pythagorean theorem, but the hypotenuse is A. That's the longest distance. All right, so now we're going to do some problems. All right, first problem. Are you awake? Maybe you should stand up. Stand up, do a couple jumping jacks in the front row. You see I'm doing my jumping jacks. Lauren, Molly, maybe you need to get up, do some jumping jacks. All right. Danielle, how about some push-ups? Can you do push-ups? Josie, a couple push-ups. You gotta get on the floor, push yourself up. All right, are you awake? All right, first problem. Write an equation of ellipse with center of the origin. So we're gonna start out basic. Center 0, 0. And the formulas we just went over are for a center at the origin, 0, 0. Okay. And we're given some info. All right. We're given a vertex and a co-vertex. Okay. How do I know which one's a vertex, which one's a co-vertex? Well, the letter associated with the vertex is A. The letter associated with the co-vertex is B. And remember, A is always greater than B. So if the center's 0, which one is the vertex? 3, 0 or 0, -1? Well, the longer one, which should be the vertex V3. And this is co-vertex. All right. So if I were just to do a sketch, of course you don't have to, we're going to write the equation. The vertices would be at 3, 0 and -3, 0. Vertex. Co-vertices 0, 1, 0, -1. All right. Now that's a little bit off here. And here we go. Here's your little ellipse. Okay. Now, equation of ellipse. It's x squared over either a squared or b squared plus y squared over a squared or b squared equals 1. All right. What's the major? The x or the y? Well, the major is the longer one, so the x. That means my a squared goes under x squared. B squared goes under y squared. All right. A is the distance from the center to a vertex. A is 3, so we square that. That's 9. B is distance from center to a co-vertex. These are my CV. That's 1. And 1 squared, b is 1. It's always positive. The distance is positive. 1 squared is 1. All right. Now, y squared over 1 is just y squared. So here's your final answer. Standard form. Okay. Next one. Write an equation of an ellipse given a height and a width. A height and a width. This is wider compared to its height. Okay? And the width is the entire width from one vertex to the other vertex. All right. So if it's 32, I divide that in half. My a in this case is going to be 16. So this is going to go from negative 16 all the way to 16. This is a vertex. This is another vertex. All right. Now I got to go half of 15. All right. My b is 15 halves, which is 7.5. So 6 there. If I were to draw it, this is a little sketch. Okay. All right. Write an equation. All right. To write the equation, you need the center, which is 0, 0, and you need a and b. All right. What's my a? 16. B is 15 over 2. 15 halves, 7 and a half. All right. So I have x squared plus y squared equals 1. All right. Now again, this is a wider one. So x is the major. So a squared goes under x squared. 16 squared, 256. Now what's b squared? I'm going to square 15 halves. That's 225 over 4. Right? But we can't have a little complex fraction, right? This is a fraction within a fraction. So we're going to simplify this. How do we do that? Think back to last chapter. I want to get rid of the denominator. This is 4, so I'm timesing the numerator by 4. The denominator by 4, the 4's cancel, and my final answer is x squared over 256 plus 4y squared over 225 equals 1. Just because I don't want this complex fraction. And I definitely don't want decimals. All right, next one. An equation of an ellipse given foci and co-vertices. Okay. What's the letter associated with the foci? That is C. And the co-vertices, B. Okay, let's just sketch this out. Foci are at positive, negative, 5, 0. I'll go 2, 4, 5. Here's first focus, negative 6. So there's second focus, negative 5. All right, and remember the foci are on the major axis, so X is the major. Okay. Co-vertices, 0, 2, 4, 6, 8. This is a co-vertice, 4, 6, 8. Now I can't really draw it yet because I need to find my vertices. All right, meaning I need to find A. Okay, how do we find A? Well, we use the Pythagorean theorem, but with the letters switched around. A is always the largest number. All right, so this is going to be B squared plus C squared equals A squared. Okay, B is 8. So 8 squared is 64, plus C is 5. 5 squared 25 equals A squared. Add them up, A squared is 89. Okay. To find A, we'd square root 89. And that is what? Grab the calculator. Square root 81 is 9, so square root 89 is about 9.4. Okay. So we'd have 4, 6, 8, 10, 9.4. Vertex, -6, -8, -10. Vertex. So here it is, a little sketch. It didn't ask us to sketch it, but we're sketching it. All right. But really I want to write the equation. So it's x squared, y squared. Major axis is again the x, so a squared goes under there. I really just needed this 89. All right. B squared, 64. Done. Right. This is your a squared, b squared. Okay. Now we'll do a few more graphs and finding the foci. I really want you to use graph paper. I'm a little stretched right now at this point, so I'm not using the graph paper on these. All right. But please, on the homework, if you're asked to graph, use the graph paper. Okay. The last ones we were just sketching, but these are actual graphs. All right. Here's the equation. Right? X squared over 64 plus y squared over 100 equals 1. This is in standard form. Good to go. All right. How do I know what the major is? Okay. Well, a is always the biggest number. All right. So is this a squared or is this a squared? Okay. Well, just go for the bigger one. 100 is a squared, 64 is b squared. So my y-axis is now the major. So this would be a taller one as opposed to a wider one. All right. And a is a square root of 100, which is 10. That means I have a vertex at 0, 10, and 0, negative 10. So we're going to label our vertices 0, positive, negative 10. Okay. Vertex 1, B2. Co-vertices. B is square root 64, A. So the co-vertices are 8, 0, negative 8, 0. Co-vertex 1 and 2, positive, negative 8, 0. I can draw it. Right. This is a little taller one. Now, because I didn't use graph paper, it doesn't look so great. But this is what we got. And it should be perfectly symmetrical. Right. Lastly, we're going to find the foci, and we're going to use the Pythagorean theorem, but with the letters switched around. It's b squared plus c squared equals a squared, because a is the longest. Okay. B squared 64, c squared I don't know, a squared is 100. All right. Subtract 100 minus 64, 36. C is 6. Works out great. Doesn't have to be a perfect square, but it was. What are the foci? They are on the major axis, which is the y-axis. The foci are at 0, positive, negative 6. And we'll put them on there. When you graph 2, 4, 6, you want to have the center, vertices, co-vertices, foci. And it's complete ellipse. All right, one more graph. Now, is this in standard form? No. Okay, how do I get it in standard form? It has to equal what number? 1. So I need to make 64 a 1, so I'm going to divide everything by 64. All right, equals 1. And then I reduce. 16 64ths is 1/4. Plus 4 64ths is reduced 1/16. Okay. And of course you can put that in your calculator if you're not sure. You can go 4 divided by 64, math fraction. Okay. Okay. Now, standard form, just like the last one. And it looks like y is our major axis again. So this is a squared, and this is b squared, because a is always bigger. A is the square root of 16, which is 4. B is the square root of 4. I got that wrong. B, which is 2. Okay. But remember, Vertices, co-vertices are points. All right, y is the major. So I'll go 1, 2, 3, 4. And 1, 2, 3, 4. And label. Vertices are 0, positive, negative 4. Okay. It doesn't matter. You can, this is V1 or this could be V2. All right, co-vertices are 1, 2, negative 2. All right. CV1, CV2. All right. That's positive, negative 2, 0. Here's a nice little picture. This one looks a little better than my last one. But remember, you're using graph paper, so yours will be perfect. Okay. Now, lastly, we find the foci, and we use b squared, 4, plus c squared, I don't know, equals a squared, 16. Subtract, you get 12. This is typical. You don't get perfect square. All right. C is, this is 4 and 3, 2 square roots of 3. All right. And what is the square root of 12 about? Well, we can put that in our calculator. That's about 3.46 or 3.5. All right. So remember, foci are points, though. What are the foci? Our foci are going to be exact 0, positive, negative 2 square root 3. This is called the exact. Then the rounded are 0, positive, negative, about 3.5. So that's about here, F1. Here, F2. Right. But we want to label. Right. Either the exact or the rounded. But you really got to round it to get it on there, on your graph. Okay. All right. Lastly, what are we going to do? Translate. Up, down, left, right. The center does not have to be 0, 0. The center, okay, can be moved, all right, either left, right, or up, down. The center will be H, K, all right? H moves it left or right, K moves it up or down, all right? So now, we're gonna add to the standard form equations, all right? If the horizontal axis is the major, which was the x, but now we may move it, you may move it up or down, okay? What's our equation now? Well, instead of x squared, it's x minus h quantity squared plus, and then instead of y squared, it's y minus k quantity squared equals still 1. And when x, the horizontal, is the major, you have your a squared under the x and your b squared under the y. So then for vertical, we just switch. A squared to b squared. Okay. So now under the x squared is the b squared. Under the y squared is the a squared. All right, and remember the a is always bigger, so you'll know what is the horizontal based on the bigger number under the either x minus h squared or y minus k quantity squared. All right, so we'll do an example. Okay, this will be our last one. Writing an equation of an ellipse, center, all right, hk, 1, negative 4. The horizontal major axis, all right, has a length of 10. Right? And the minor axis then would be vertical, and it has a length of 4. Okay. So to write the equation, normally we just need a and b, but now we also need h and k, 4 things. All right. So we'll start out x minus h minus 1 quantity squared plus y minus k, double negative, so plus 4 quantity squared equals 1. All right. Now, horizontal is the major. Okay. That means a squared goes under the x squared, b squared goes under. How do I find a? All right. Well, the major axis length is 10. Okay. okay? The entire length. Right? So all you do is take the major axis length and you divide by 2 to get your A. So A is 5, and A squared, 25. Your minor axis length, okay, is 4. So I got to take that, divide by 2. My B is 2. Okay. But 2 squared, 4. Here's the equation. Okay. You need HK, you need A and B. Now we're going to graph. Okay. Ready to graph. The center, let's see, 1, negative 4. All the way down here, that's the center. Instead of 0, 0, it's down here. Okay. This is shifted 1 right, 4 down. Okay. Now, horizontal, X is the major, but it's shifted 4 down. Okay. My vertices will be 5 from the center. Okay, so I count over 1, 2, 3. Let's see, 2, 1, 2, 3, 4, 5. Here's the first vertex. All right, so really 1 plus 5, that gives me 6, negative 4. Then 1, 2, 3, 4, 5. I'm at, looks like negative 4, negative 4. We're going to label both of the vertices. Then the co-vertices, the minor is vertical. I'm going to go, B is 2. I'm going to go up 2, down 2. So CV1 is 1, negative 2. The second co-vertex is 1, negative 7. And here it is. The line. Now, this is a perfect drawing, okay? But we also want to always include the foci. So lastly, I'm going to use Pythagorean theorem switched around because A is the longest. Okay. B squared is 4 plus C squared, I don't know, equals A squared 25. C squared is 21. C is the square root of 21. That's about what? About 4.58, 4.6. Okay. All right. Not that different from A. Of course, it's smaller than A. A is 5. All right. But this is a longer one, so as they're longer, the foci get closer to the vertex. Right? So where do I put the foci? I start at the center, and I go about 4.6 to the right and 4.6 to the left. All right, so 1, 2, 3. 1, 2, 3, 4.6 to the left. Focus 1. 1, 2, 3, 4.6 to the right. Focus 2. Okay. Okay. Now, what are those? The exact foci are, you start at 1 and go plus and minus the square root of 21, and then the y value is negative 4. Okay, this is exact foci. The rounded foci are at 1 plus 4.56. That's about 5.5. I'm sorry, that's 8. Negative 4. And 1 minus 4.58. That's negative 3.58. Negative 4. Or negative 3.6. This last guy. Right. So these are problems with an ellipse. All right. The third of 4 conic sections. All right. So good luck. There will be an assignment, and I hope it goes well. Have a good day.